at least. So we've got a really fantastic panel of speakers for Design to Manufacture, and welcome if it's your first time on this webinar series. So we're going to do a quick bit of housekeeping so you know what's going to be happening today, and also you know how to use all of the controls on the system. So at the bottom of your screen you'll see the chat box. If you can type in the chat box and let me know that you can see the holding slides, and also let me know that you can hear audio. I'm going to get our speakers to unmute and just test their audio. So Abby, if you want to check your audio, make sure we can hear you okay.
Thanks, Anita. Hi, everyone.
Brilliant, thank you. And Hannah?
Thanks, Anita. Hi, everyone.
That's great. And Hussein?
Good morning, everyone.
And Francis?
Morning, everyone.
And Carl?
Morning.
And Reg?
Hi, folks.
Excellent, that's great. So everyone's confirming that sound is clear, and also that the screen, the holding slides are up. So you will have a chance to ask questions to our panel. So if you've got any questions at all, you can type those into the chat box by using the letter Q or putting the word question in front of your question, just to make sure we can find it easily between all the general comments. You can also use chat box for networking, so please do send in information about yourselves you want to share with others, and so others can copy those and connect with you offline. You know, share all your experiences. Feel free to do that, your manufacturing experiences, design, also tech as well. That would be great for everyone to hear about that. And also, if you have a lengthy question, you will be able to unmute yourself and ask it verbally. So if you want to do that, then just press the raise your hand button in the reactions, which is at the bottom of your screen, and then Abby can get you to unmute yourself. But otherwise, Abby will be reading your questions out, as she'll be finding them in the chat box, and all our speakers will then be answering them. And then finally, we'll give you a chance to have some very short and informal networking at the end of the session. So if you want to take part in that, please do stay on for that. We'll be putting you into breakout rooms where you'll get a chance to unmute yourself, just introduce yourselves and just have a chat really, and meet some new people, and hopefully make some good, powerful connections. So without further ado, I think we're pretty much ready to start. So Abby, let me know when you want me to press record.
Yeah, let's just go for it, Anita. Will we just get started? Be sharp, and yeah, people can join in when they arrive. So hi everyone, very warm welcome to week 10 of our Made Smarter Innovation Network series. This week the webinar focuses on design for manufacture, which is a subject I'm personally very passionate about, and one that unites all our KTN manufacturing team activity. Although we can optimise the supply chain and manufacturing processes, and that sort of area of activity ends up absorbing quite a lot of attention. It's often for quite marginal gains. But around 80% of product costs, depending on sector and technologies and so on, is locked in during the design for manufacturer decision making. The choices you make in these early stages impact on the manufacturing processes you use, the process efficiency, logistics options, product value, life cycle, product cost, etc. Once you invest in the production line and the material and the stock for your product, it's difficult to undo those decisions. Change becomes increasingly expensive the further through the process you go. So there's huge opportunity in design if we can get it right. So this session is going to look at digital technologies and how they can improve design for manufacturer decision making. We'll look at different types of decisions that need to be made, the implication of poor decision making, and the range of technologies that can support design for manufacture. So today we've got a really great set of speakers. We'll kick off with Hannah Leslie from the National Manufacturing Institute in Scotland, who will provide an overview of the use of these technologies to support design for manufacture. We'll hear from a collaborative trio who've worked together. We'll hear from Hussein Torabmostadi from Unipart, who have utilised an immersive CAD product from Masters of Pi, and with support from Francis Hamilton, who's founder at DirectTech. So we'll have Hussein Francis, and then Carol Maddox is going to talk about the Masters of Pi from a technology point of view. And our final presentation today will be from one of our round 2 Made Smarter Innovation R&D grant awardees. From Reg from I4 Product Design is going to share insights and plans for utilising digital technologies to improve design decision making around cost of tooling. Then, as usual, we'll have our Q&A panel with all 5 speakers, plus time for informal networking, helping you to connect with the community of manufacturers, innovators and other stakeholders. So, yeah, hopefully, if you've joined us in the series, you'll know by now that KTN exists to make powerful connections, to enable positive change and to help you innovate. So collaborations and relationships, as I'm sure most of you know, are so key to commercialisation. And we're here to help you facilitate that. So this includes connections to funding, expertise, facilities, technologies, investors, academics, and other sectors. So as a network, we've got a wealth of knowledge and expertise that covers a whole range of sectors and technology areas. We are experts in network innovation and have been a trusted partner of Innovate UK for many years now. So I'm really excited to get to the speakers, but I've been asked just to set the scene a little bit about why we're doing this series. So you may be familiar with the Made Smarter review, which was published in 2017 when Jürgen Meyer led a team of industrialists to look at how digital technologies can help accelerate productivity in UK manufacturing. So from that review, there was 4 sort of areas that were identified as opportunities. One was adoption, innovation, leadership and skills. And it's the innovation strand of that programme that we are most interested in today. So it's led by the Industrial Strategy Challenge Fund team at Innovate UK, or the name's kind of in transition, so it's Made Smarter Innovation now, as it's currently known. So over the next 3 years, the programme will be investing 300 million in supporting manufacturers, digital technology developers, founders, and academics to innovate solutions to increase the productivity of manufacturing in the UK, with a view to helping us export these solutions to the global manufacturing community. So there are a number of interventions underway already. For example, collaborative research and development programmes. There's a Made Smarter Digital Accelerator. There's pilot innovation hubs. And further information on all these interventions can be found on our website. And we're going to hear from one of the beneficiary companies today. So that's quite exciting. So the networking activity, the bit that KTN looks after, such as this webinar series, aims to promote communication of the latest project technologies and developments and develop a community of collaborators innovating to support productivity improvements in the UK, way past beyond just what's funded through the Made Smarter initiatives, the CR&D type programmes. So there's so much awesome work going on around Made Smarter innovation in the UK, around technology development. The portal is going to be a way of sharing stories. Our community will be a way of sharing stories. So do please get in touch if you've got a story to tell, either by sharing one of these links or just by getting in touch with us directly. And one more opportunity to mention is Innovation Alley at Smart Factory Expo. This has been so exciting for us as a team. It's a chance to find out about new companies in this area and shout about what they're doing a little bit, share what's going on really. So it's an opportunity for digital startups to exhibit, hopefully live this year at Digital Manufacturing Week. So getting a spot is quite a big deal. It's pretty competitive and hugely valuable in terms of meeting manufacturers, raising your profile, etc. So if your company is suitable, or you know somebody who might be suitable, please get in touch or encourage them to get in touch. Let us know. And we're starting to look for these companies now. Okay, so without any further ado, I'm going to hand over to Hannah Leslie. So Hannah is a business development executive in the design engineering team at National Manufacturing Institute Scotland, which is one of the high value manufacturing catapult centres. they bring industry, academia and the public sector together with the aim of transforming UK manufacturing. So Hannah's going to share some ideas about digital technologies and how they can be utilised to improve the design process. And she's going to share some case studies as well. So yeah, I'll hand over to you, Hannah.
Brilliant, thanks very much. I'll just take over the slides. So can everyone see that okay?
Yeah, perfect, Hannah, thanks.
Perfect, thanks very much. And thanks everyone for joining us today, and Abby for the introduction there. So I'm Hannah Leslie. As Abby says, I work in the design engineering team in the National Manufacturing Institute Scotland, or NMIS as it's kind of more commonly goes by, where we work with a real range of companies with their product development journeys, including design development and the verification and validation activities that go along with it. We also support companies in accessing funding for these development projects where necessary, and signposting to a lot of the other partners in our networks. So as Abby has mentioned, then this group kind of aims to bring together academic research groups, industry and manufacture, and the public sector to transform skills, productivity and innovation, with the aim of enhancing Scottish PLC and UK PLC, and establishing ourselves as a global leader in advanced manufacturing. We're operated by the University of Strathclyde, but it's established with stakeholders from across Scotland. In terms of how it's set up, just for those of you who aren't aware, it's got two specialist centres, specialist facilities. The Advanced Forming Research Centre, which has been operating for about 10 years now. It's kind of the first centre that NMIS has grown out of, and the Lightweight Manufacturing Centre, which is more recent. NMIS will also operate a number of core elements, so the Manufacturing Skills Academy, which currently hosts a number of professional development courses. The Digital Factory, which the design engineering team is part of, alongside the digital manufacturing team. We've obviously been working remotely for some time now, but one day we'll get back and we've got a new facility to go back to out near Glasgow Airport. And as part of that facility, there'll be a collaboration hub where companies can come to work together. Importantly, though, we are operating right now, today, and we do have the capabilities available. So please get in touch or catch us online if you'd like to know more about the actual physical development too. So to kick off at a pretty high level in terms of design and product development, this diagram shows the kind of stage-gated product development process we typically use loosely in NMIS. It starts from the spur of an idea on the left and follows the process all the way through to making that idea an in-service reality on the right. So the term stage-gated here means that at predetermined stages, review meetings are held to consider the work completed to date. These reviews would include input either before or during from key stakeholders and subject matter experts, with the objective to ensure that the work to date conforms to requirements and is sufficient to proceed, or requires further work, or maybe even abandoned or rethought completely and go right back to the drawing board. You should freeze the design after each successful review in order to ensure everyone is clear on the design intent, especially if there's multiple stakeholders or it's a system design, and that everyone will be aware of any resultant impact with respect to especially cost and lead time for any changes made outside of this process. In product definition, the first stage, you'd use your knowledge of the market and your product idea to generate a product design specification or set of requirements, which you then take into conceptualization, where you generate your number of concepts for viable solutions and assess these against the requirements to establish which fulfills these needs best. It's also an opportunity to identify features and aspects of concepts which can be combined to improve the overall concept and design. In preliminary design, the chosen concept goes through verification checks and initial verification to establish that the concept can perform the intended function and possibly optimize the geometry a little bit at this stage. This is where you'd also start your CAD modeling in earnest. In detailed design, the focus is on manufacturing and materials for the concept, moving it into a state where it can be manufactured through the production of general arrangement, GA drawings, and bills of material, and so on. Once you've got your pre-production prototype in the validation stage. And that's not to say that you won't have already produced a number of low fidelity concept models. You'll complete testing on this to ensure that the product can perform its functions safely and provide evidence for this. And then finally in manufacturing, where the initial production run will be run, and any issues encountered can be investigated and resolved there before you move to full commercialization. So as part of this design process, I wanted to highlight just some of the many digital enablers and digital tools that we use either in the design engineering team ourselves as part of standard work, or that are not used by us but that are commonly used in industry, or that are quite early stage and still have some development to be done before being fully adopted by industry, but have the potential to be really impactful. I've tried to show roughly where they might be used on the development timeline, but to be honest, a lot of them are used throughout, or that it's not really that clear cut, and some are more processes and frameworks rather than standalone activities and tools. So I'll start right at the beginning when you're setting your requirements, potentially as part of a system design or a product family. Many expanding companies use requirement management systems and software. These are used for documenting, analysing, prioritising and agreeing on requirements so that engineering teams always have current and approved requirements. Requirements management provides a way to avoid errors by keeping track of changes in requirements and fostering communication with stakeholders from the start of a project throughout the engineering lifecycle. Moving on to another obvious one, one that's used all the time. It's taught in higher graphics classrooms, but that's 3D CAD or computer-aided design. CAD software is also a common feature of the iterative design process, so it allows designers to create and tweak designs digitally in 2D or 3D form. And at this stage, you might also use 3D scanning and metrology for existing parts to establish interfaces and space constraints. Generative design and topology optimization build upon the traditional design approach by applying computational power and optimization techniques to component design. So both aim to help designers reduce both the weight and the amount of material used for a specific component whilst maintaining its structural integrity. General topology optimization takes one complete CAD model concept and returns an optimized concept for evaluation based on the human design model, and returns to the user an optimized mesh model result. Whereas generative design begins with requirements and holdout areas, preserved areas, loads, constraints based on the project requirements, and then it determines multiple optimized topological concepts that are created for evaluation based on the criteria. These are both most used in anger at the moment with additive manufacturing. However, we are involved in some work with the high value manufacturing catapult, exploring applying it to other more conventional manufacturing technologies. And we're also going to be co-hosting some generative design, machining and additive manufacturing workshops with Autodesk in the future. So keep an eye out if you're interested in that. Cost modelling software is another one that we use really regularly as part of our development projects. Reg and the team at I4 is doing some really interesting things, specifically in the injection moulding space. So looking forward to hearing about that later on. We use a software in the centre called SEER by Galarath. It allows us to look at cost drivers across all different manufacturing processes, materials and geometries to understand and optimise for cost. And lifecycle analysis software is another one that's becoming really prevalent and is used to identify the environmental risks of existing and planned products, services, and manufacturing processes. Mathematical modelling and first principles are obviously pretty fundamental, but can be combined with other elements of design digitalisation to automate and optimise concepts. So for example, one of our Tier 2 members, the engineering company, has built a platform combining mathematical modelling, generative design, 3D CAD and engineering analysis that powerfully kind of drives concepts based on the product requirements, and they're aiming to move towards more digital validation activities. In engineering analysis, so this is simulation, modelling, FEA, CFD, these all come under engineering analysis, and that's basically using a variety of digital systems to assess engineering performance and verify a product or component against certain requirements. So for example, stress, strain, thermal distribution, and so on. Model-based systems engineering is a an approach using a systems model. So it represents all users and processes within an organization. And it's built around a defined set of rules or a language that's created using a dedicated software. The system model acts as a single source of truth for data and documents, and all other artifacts are automatically generated and shared with stakeholders using this software. And finally, product data management, PDM, and product lifecycle management, PLM software are commonplace in industry. PDM is specifically for managing CAD data and revisions, and allows checking in and out of documents to ensure only single users are editing at once. And PLM software is common in larger organizations and includes all the functionality of PDM, but PLM, product lifecycle management, goes further and includes change processes and workflows, bill of materials management, filing of other design and product related documentation, as opposed to just CAD data. So, for example, technical product documentation. These systems massively streamline the engineering change management process and can largely automate change request processes through the use of workflows. So that was a real whistle-stop tour of a number of the tools and systems available that really enable a better design process through increased efficiency, reduced costs, increased accuracy, and so on. This overall design digitalization is also carried through when going towards manufacture, so using AR and VR, production processes, automation, and digitalizing business processes. So it is a really exciting space to be in at the moment. I'm certainly not an expert in all of these digital tools that I've discussed today, but I'd be more than happy to engage with you and introduce you to our engineering teams at NMIS to discuss in more technical detail. So please do get in touch if you'd like to chat more. As I said earlier, NMIS is looking to support all kinds of companies with their manufacturing journeys. We really strive to work with companies to provide access to manufacturing and academic expertise, access to specialist equipment and facilities, and we do support companies looking for public funding and developing bids. And we can support to our wider networks too, where appropriate. So yeah, thank you very much for listening.
Thanks so much, Hannah. That's really appreciated. What a great overview of a whole range of technologies that are available to help support this process. So now we're moving on to a case study with a trio of innovators who've worked together. So we'll start off with the manufacturer and then a supply chain provider back to back, and then we'll move on to the tech provider afterwards. So in terms of the manufacturer, we've got Hussein Torab-Mostadi, who's going to give us an overview of what's going on with Uniparts. And then we've got Francis Hamilton from Direct Tech, who's going to tell us a bit about how their technology has supported the collaboration. And then we'll pause and I'll introduce Carol after that. So yeah, Hussein, if you're ready to take over, that would be fab.
Yeah, thanks, Abby. Yes, so Hussein Torab-Mostadi from Unipart Manufacturing. Just a quick overview of Unipart Group as a whole. You probably know us a lot about, heard about the logistics business, which is a global business, more than 8,000 employees across the world. But we also have many other businesses that we're operating in the UK, predominantly manufacturing and rail. Rail extends to the global as well. We have many customers like Sky, Apple, JLR, Waterstone. So what we deliver to customers is basically the end-to-end solution from supply chain, logistics, manufacturing, rail. Is basically what we can do to help our customers throughout their journey and life cycle. Manufacturing business in the UK predominantly produced components for internal combustion vehicles. And as you probably know, that industry is changing towards 2025, 2030. That is a sort of immense ramp down for those components. The requirements becomes obsolete, and we have a ramp up for electrification and electrified powertrain components. As a business, in rail and manufacturing for automotive industry that we're working with. That means for us, we have to do that transition for our sites, for our manufacturing capabilities. And we might need to do new sort of business model, run new business models to enable those and sort of businesses to move forward, and what that means for us. For us, we're moving away. If you look at, for example, the components that we have, like fuel tank in the business, that is 30 to 100 components or parts in a bill of materials.
Hussein, sorry, Hussein, we can't see your slides. I'm not sure if you're supposed to be sharing them or if you're just talking. It's quite clear. I don't think slides are needed. It's working.
I have shared. I will share again now.
Perfect, thanks.
Is that okay? Apologies. Is that okay, Abby?
Yeah, that's great. That's it. Thank you.
Yep. So what that meant for us is the market is changing. The product's getting more complex. If I just talk about the sort of fuel tank, we have 30 to 100 parts in bill of materials, and we didn't have any live electronics, and it was simple. We used to manufacture that part for over 30 years, and we knew how to do it. The supply chain was clear, and it was all easy. When we get to now electrification and we get to something like a battery pack, we're talking about 15,000 parts in a bill of materials, and we are talking about battery management system and 800 volt sort of a system, which is very sort of dangerous in terms of safety and sort of storage and everything that we deal with in the shop floor. What that meant for us in our operation meant sort of we had to become more collaborative. Imagine you're moving away from 30 parts to 15,000 parts. What that means from the design perspective, what that means in terms of the handover between design and manufacturing, how manufacturers now needs to sort of collaborate with the tier 2s and tier 3s, finalize the design to agree on the cost, and sort of trying to sort of agree that with the OEM. If you want to continue doing what we used to do in the past with the simple products, that wouldn't have worked. We had to become more collaborative, and that's how the industry is changing. The whole product development, product introduction industry is getting more collaborative. And one of the major things to enable that collaboration within the new ways of working is the system syncing and the faster decision making. What that meant for us as a business, we had to create a system topology in the business to create that sort of dotted lines between supply chain, design, manufacturing, and customer, and every functions that goes around between this value chain. For example, what we have done between the design house, actually when the design, for our case, in our battery business, which is a joint venture between Unipart Manufacturing and Williams Advanced Engineering, the Williams team do the design. So we collaborate for that design in our PDM that Hannah was talking about earlier, product data management, which what that means is whatever they are doing, CAD, drawing, BOM, bill of materials, we have actually a synchronized instance between us, which we're working on a single source of truth. If any changes happening in design, and we're not talking about post-design, we're talking about now before design freeze. If any changes happening to the design because of performance, because of customer requirement, whatever that change is, manufacturing is going to be aware of it. Once manufacturing is aware of that change, we coordinate that change with the suppliers through our supplier portal or supplier collaboration portal, which we share the CAD, we share the drawing, and we actually tell them what has changed. What they need to tell us then, what is the impact of that change on the cost, on the timing, on the lead time, and everything else, and then how we can sort of communicate that back to the design if that's acceptable or not. But that change management, that BOM management, data management becomes very important when you're moving from 30 parts to 15,000 parts, because you need to get that right. And the big part of that, which Reg is going to talk about later in the call, is about the part costing. How all of these things got to impact the cost. And when it comes to cost, we have the part cost, we have the tool cost, and how we're going to work that out with our customers. So it's very, very important to make sure that you have that system in place to have that synchronization between design house, supply chain, and customers to make sure you get all these details right. Beyond that, I think we talk a lot about engineering and design, but what that means when it comes to actually manufacturing that product. We worked with the consortium of partners. DirectTech is part of that consortium, and the program was supported by Advanced Propulsion Centre Innovate UK, which gave us that support and funding that we needed to work around these things, was to actually think broadly from the point that we want to design to the point that we agree the design is frozen, we work with supply chain to get the parts, the point that we get the parts, and now we want to plan our manufacturing processes. We planned our processes, we do the validation of our processes. Now, what the tasks are for the machines on the shop floor, if there's any changes on the shop floor, how that change is going to be communicated back to the design, to the PDM, to the design, and then to the supply chain. All that architecture and topology is something that we have been working with a range of partners to define and sort of deploy. And the whole point of that was we have to become systematic. We have to put these links and integration in place to make sure that we can move together as a team to enable that product to come to the market. And requirements and a speed to market is not going to get easier. As you all know, with the move towards autonomous vehicles, automated vehicles, is just the customization becomes a major thing. And that customization means we need to be flexible. And for us, that flexibility means we all as a whole, between design, supply chain, manufacturing, and customer, we all need to be flexible. And that system is going to put in place that flexibility. Some of the things that I made a note here, these are some of the things that we're working with our partners. It's not simple. If you go deep into every one of those topics, when it comes to integration between your manufacturing and your financial, when it comes to integration between your shop floor and the systems, when it comes to costing, for example, how that costing is going to communicate to the suppliers and how you're going to get the result back is a very complicated subject. It's not easy. There might be claims that systems are there and they can deliver it, but it's all you need to work with a range of partners to make that bespoke to your needs in the company. And you saw all those complex diagrams. When it comes to actually in running the business now, we've all deployed this now. It's all up and running in our IT infrastructure. What that means for each department, we had to do a major piece of work to make that relevant to each department, to quality, to supply chain, to production, how they're going to use these tools and capabilities in their planning, in their execution, in their root cause audits, in their intelligence, and into their compliance. And once that architecture in place, then every department knows now when it comes to design for manufacture, design for assembly, design for testing, where they need to use the tools, how they're going to use it, and how they're going to communicate to wider companies and value chain. Some of the things that I want to say as ingredients and challenges in our journey was you have to have the funding to enable this sort of transformation and journey and enabling these technologies into your business. And for us, we have been fortunate enough to be supported by Advanced Propulsion Centre Innovate UK through the grant funding to be working with partners to enable that. The second thing is working with vendor agnostic partnerships. You will hear from Direct Tech and Masters of Pi later on. These are the partners that are not tied to a specific vendor, and they can actually work with you to define that topology that I've showed earlier, to make sure that you realize what you need and what is the pain point in the business. You're addressing those, and then once you understood exactly what that means, what the integration means to your supply chain customers, then you can actually go out and become more specific in your system topology and system. Just say what those ingredients are, what specific vendors I need to work with. And once you have defined that, when it comes to implementation, that becomes easy. You have the funding, you have identified vendor agnostic sort of topology, you have the vendor specific topology included, and now you're going into the implementation with vendors. The other major things that we have been working on was training and skills. These are all rare breed technologies and skills. If you go out, if you start looking for jobs, if you search for PLM, PDM, MES, CAD, you will see what kind of range of salary people are looking for, and how tight the market is in terms of the skills. So we are working with universities now. Our partner is Coventry University at the moment, which we're basically cloning our systems, and they are working on our systems, teaching the students on those subjects. And when they come out of the university, they actually train our systems. If you're a smaller company, find a university that you want to work with, and then sort of clone your requirements with them and make sure that your subject is included in theirs, or actually learn from them what subjects and what technologies they're using to make sure that the skills is not a problem once you have rolled this out and made this investment. And the last of all is extend and improve collaboration. Once you have that topology in place, it's all about extending it and improve the collaboration. I'll talk too much, but what I want to say now is those two topics here, the supplier collaboration and the design for manufacture that I've talked about earlier, are those that Francis and Carl are going to talk about in the next slides, and the good work that they've been doing. But without those sort of touch points and sort of collaboration with supply chain and design house, this is that move to electrification, that move to complex products becomes a major problem and major drawback for the UK manufacturer. Thanks, Abby. Francis?
Thank you, Hussein. Did you want to say something, Abby?
No, I was just going to hand straight over to you, Francis, if you've got your slide there.
Yes, I will share my slide. Sorry, thought Hussein was going to share that.
Yeah, I thought so too. I was expecting it to continue. So, yeah, Francis is the founder at Direct Tech, who are a specialist in data engineering. And they've worked with Unipart to deliver this digital collaboration between the supply chain, the designers and manufacturers. And they really
can you see that?
Yes.
Perfect. Thanks, Francis. On you go. Take it away.
Okay, so thank you very much. Thanks, Hussein. Yeah, Direct Tech, we're a small company. We started in 2018. And as Hussein said, we are part of the Innovate UK Advanced Propulsion Centre sponsored collaboration project with Unipart and Williams Advanced Engineering as their major partners. Our challenge within the overall requirement to build a battery pack manufacturing plant in the heart of the United Kingdom is to be the digital collaboration platform. So without data in this new world, you have, data is the foundational layer. Data is the one thing that will enable you to access all the smart new technologies and innovations that are coming out there. So we have built a digital collaboration platform primarily to connect the supply chain to the designers and then through to the manufacturers and out to the customer. So it's an end-to-end data supply chain to erase the silos that you find in your various software pockets, that you might have information contained in somebody's head, in somebody else's email system, on somebody's desk on a piece of paper, and try to track and retain a single source of the truth so that the manufacturer or whoever the client is can not worry about the administration and the burden and the overhead that carries, but focus on easier collaboration with the suppliers, with whoever they need to deal with to get the very best out of the skill set and the knowledge base that's being afforded to them. So this single slide is to try and show you the iterative process that you go from design to manufacture, and wherever in that loop you start, you will have information passing from one stage to the next stage. You might then have people going off on their own and thinking, oh, I've had an idea, I'm going to make a change here. That's fine. But if they don't pass that on up the food chain, everything stops, because it's not until you and the person that you're working with look at the same diagram or the same piece of information that you realize that one person's looking at version 4, the other person's looking at version 8. Then you've got to stop, work out whether version 8 is better than version 4, and the person that's been working on version 4 needs to catch up to version 8 before you start again. And right from the outset of this project, the biggest challenge that Unipart and Williams spotted was moving that dial to the left to try and encourage the design, the conceptual design through to the validation, cost modeling, and locking everything down, and then bringing the supply chain in, bringing the manufacturing team in so that they can start planning the manufacturing space earlier, and they can flag up any issues like, well, to do this, you're going to need this piece of tooling that needs an arc of, 3-foot beam. So we can't get that in the space we've got at the moment. If you can squish all that up into a smaller packet of information and enable everybody to see the elements that they need to see to help them do a smarter, more knowledgeable, more informed job, then we have done our job in delivering the baseline data to inform that, despite the fact that that will then integrate into all the different software packages that become the systems of record, whether that's your ERP system or your PLM system, PDM system. The acronyms are endless. But in a nutshell, this is the foundation. Without this foundational layer, your Industry 4.0 technologies, which are powerful, strong tools to really help move the dial and make us more productive and more innovative, none of those are possible without the baseline data. So I will now hand over to Carl Maddox, who will tell you how that data is helping them inform. Thank you.
Thanks so much, Fran. Thank you, Bill. So Carol's CEO at Masters of Pi, who are the software collaboration platform in this collaborative mix. So yeah, over to you, Carl.
Great, thank you, Abby. Are you able to see my slide deck okay?
Yeah, perfect, thank you.
Okay, great. So yeah, we've been involved with both Unipart via Hussein and also Francis at Direct Tech here on this, tackling the problems that Unipart specifically have, as mentioned by Hussein there. And I guess, first and foremost, Masters of Pi, we're a software company. We're in the business of collaboration and enterprise collaboration. We're heavily focused towards spatial environments, so immersive tools like augmented reality and virtual reality as the kind of the primary delivery platform for any kind of enterprise collaboration. And as such, we are, of course, focused on the 3D aspect of the data that sits within these kind of complex landscapes. So VR and AR are spatial mediums. We're targeting heavy, complex 3D data, such as CAD, such as all the analysis information that Hannah was mentioning there. So simulation, robotic simulation, FEA, CFD, those types of things that come along with the design as it iterates. But also that landscape behind there that is kind of filled with all the other data types, both 2D and whatever that may be. So your design history, your bill of materials, and obviously as the landscape matures now, we've got Internet of Things data being layered on top of that. So the landscape itself within these complex organizations, especially in aerospace and automotive, which is where a lot of our work is focused, is a complex one. And so we've developed the collaboration SDK Radical to kind of bring that native spatial collaboration element, which is so unique and so beneficial to teams of different skill sets or teams working within outside entities like partners and supply chains. We're designed to kind of centralize all of that complex data and start to tie it all together with a singular thread. Bless you, Abby. So before I get into the specifics of the project, I think that let me just give a kind of another high-level overview of where we sit, both within the Unipart and the Direct Tech kind of stack. So if you think of Radical as the spatial collaboration environment where you can jump in and out of this real-time environment with your colleagues, with your partners, with your supply chain, and bring all of your data with you. The heavy lift is done by Radical in terms of the 3D data, but we can then, as I mentioned, start layering in supplementary 2D data as well into the mix to create these rich collaborative environments where any change from any direction is represented in real time, but bidirectionally as well. So the Radical environment doesn't just pull data into these collaborative environments for purposes of collaboration and visualization. You can also create tools to affect or edit or make changes to that data within the Radical environment, and then have that new information be kind of captured and pushed back efficiently back into those supplementary systems in the background. So as Francis was mentioning there, we would echo the Direct Tech sentiment that true collaboration really does start and end really with the access to the data. So Radical is an integrated technology in that we look for those places where the data either is generated, such as CAD packages or simulation software, or held and stored like PDM or PLM systems. Those places that exist that already been established within enterprises, they're our kind of target platforms for direct integration. So our customers, our users can take Radical and they can integrate Radical directly, natively into those software platforms where that data resides. There's a couple of benefits to that integration, one of which is obviously access to the raw data at its most raw form. So Radical can extract that data via that embedded link without the need to export, without the need to translate that data, especially when you're talking about CAD, which can be, a gigabyte or more of per file size. There's no export import process between the host environment and the Radical environment. It's done via this integration. It's all done efficiently, and just we pull through the raw data. But also we get access, whilst we have that link established to that host package, we basically have a two-way bidirectional link to that software landscape. So yes, we can pull live data through into the Radical environment, but also we can push commands back from the VR environment, say, or the augmented reality environment, and we can push those commands back into the host package to either capture changes or do things and ask the underlying host software to perform features, functionality that we don't support in Radical. So you can kind of extend that complex landscape that Hussein was showing there on his slide. We're taking all of that existing software capability and all the features that come along with that, and we're extending it out into these VR and AR environments. We still have access to the features, we still have access to the data, and then we can start connecting people up. So in the case of Hyperbat here, we have the designers at Williams, as Hussein mentioned, who's based in Oxford, and then we have Unipart and the factory in Coventry there. So we have two organizations, two environments, and Radical can facilitate remote collaboration using this live data, as I mentioned, straight from the host software to really create these more natural environments in order for different teams of different skill sets, such as manufacturers and designers in this instance, to have a smoother, more natural conversation using the data. So as part of that kind of natural collaboration, you have the added advantage of support for these immersive devices. So, probably most people by now have heard and seen the benefits of VR, but just to cover off some of the basics, virtual reality is a step change from the conferencing, which has kind of held everybody together through the pandemic, such as Zoom and Microsoft Teams. So these conferencing platforms are great for bringing people together, as we're doing now, and we can bring screen sharing into the mix as well. But ultimately, it's pretty terrible at bringing live data into the mix. Screen sharing is a very passive experience. It's not bidirectional. Most people would struggle when it comes to a 2D representation on a small laptop screen of something as complex as a CAD model for an entire factory or for an entire airplane or for an entire electric vehicle. So where virtual reality environments and augmented reality environments extend that is into the spatial kind of realm, where it's designed to mimic basically the human interactions that we do in the real world, where if you have an object in the center of the room and you bring people in, it's much easier to kind of explore that. You can walk around it, lean in, stand back, point, click, touch it, remove parts. So it's that natural human interface that virtual and augmented reality really starts to inject, which is sadly lacking in the conferencing world when it comes to Zoom, which is kind of more of a barrier to natural communication. Everybody has to mute their microphones while I'm talking here and watch my screen. It's not really a two-way natural conversation. So virtual environments really do help smooth out and kind of level the playing field when it comes to taking a complex piece of spatial data such as CAD and then bringing people in to an environment to discuss that to suit their needs. So just a quick video here to illustrate that in the case of Hyperbat. This is the electric vehicle battery that's being manufactured at the Unipart factory, the Hyperbat factory. And then here you have cross cross-team, sorry, I'll just keep a fairly short video. You have cross-team collaboration happening here in the virtual reality environment, where you're free to explore the one-to-one scale representation of the data. As Radical pulls it into these VR environments, we can create tools to interrogate it, draw markup, we can create voice notes, we can do cross sections, we can hide, remove parts, isolate it. All of these kind of digital tools that digital software like CAD brings, we can replicate and bring through into these real-time environments. So it's really it's a more intuitive, natural environment to smooth out that handover that Hussein there was mentioning between design and manufacturing. And then on top of that, you can start to layer on top of this 3D CAD all of the background information that you can pull through that direct tech system, information about the design, the supply chain, the customers, the stakeholders, the partners. All of that 2D world can be pulled through. And one thing that 3D is great for actually is anchoring that that kind of abstract 2D data. If you take Internet of Things streams, for example, tabular, they're on spreadsheets. You can then pull those into the environment and start to attach them to various parts. So it becomes a bit easier to contextualize this abstract 2D data using the 3D as a base. And then if you can simply click any individual part, those 5,000, 15,000 parts that Hussein is dealing with in his manufacturing process, each one of those has a design history attached. And in the Radical environment, you can simply click and select that particular part, and it will pull through and give you access to, in real time, all of that design history, that background data, both coming into from the design process, but also going out down the supply chain as well. So it's really the anchoring point for the spatial kind of data. And that extends eventually to augmented reality as well. I won't labor the point too much, but augmented reality allows you to bring this kind of holographic content, this 3D data, and anchor it into the real world. So you can start to augment your supply chain, augment your manufacturing line here with, I guess, holographic guides. You can start to register these one-to-one scale CAD models over physical objects to guide your manufacturers and pull in a much more richer environment from your supply chain as you manufacture. So augmented reality is going to be kind of heavily featured moving forward. These are essentially mobile devices, which means they're untethered from their desktop. So you're free to walk around factories, construction sites. We do work with the British Army now, building augmented reality for defense purposes. And, the mobile nature of augmented reality does mean that the real world starts to become a factor into your conversation as much as, sitting behind a desk looking at digital data. Which brings me to CT here, which is what we call the collaborative thread. And that's how Radical starts to sit centrally to a kind of a much complex landscape, more complex landscape. You've got CAD data from one vendor sitting in one silo. You have PLM data sitting in another silo with another team. Internet of Things data now coming in from factories, supply chain information. So Radical here can start to stitch these together and weaving this not just a digital thread which connects the systems together, but also injecting people into that, connecting people up along with that data, hence the term the collaborative thread. So just an overview of kind of the directional approach that we're taking with people like Unipart and others, is that Radical can start to leverage these enabling technologies that are coming up at the same time. As digital twin technology becomes more important to manufacturing, you have enabling technology, not just in the hardware for augmented reality and VR, but also things like 5G, Wi-Fi 6, improved, more robust communications means that we can untether our desk-based solutions and start pushing them out effectively into the real world, such as factories, and then using that 5G piece to really make that connection robust. So Hussein can start to walk around the factory knowing that his data feed is robust and he can pull through data in context, in situ, no matter where that data is coming from and what that data type is. And of course, then bring colleagues in, whether they're remote colleagues that are offsite, you can start to pull those in terms of avatars, and you start to tackle cases like remote assist, remote expert, remote training, which is really opening up the reach of pushing this digital data out into the real world. So yeah, that's in a nutshell. That's how we fit into the project and what Radical brings to the party. I think that's probably my last slide. So I'll now hand over to Reg, I believe.
Thanks, Carol. Great presentation. So good to see a visual of it actually happening in practice as well. So yeah, over to Reg now. Reg looks after software development at i4 Product Design. He's got loads of experience of injection moulding and designing products for injection moulding, and they've recently received funding through the Made Smarter Innovation CR&D program to develop software to address the need to understand the costs of tooling and costs of manufacturing early in the design process to improve decision making. So yeah, Reg, I'll hand over to you now.
Yeah. Thanks, Abby. Yeah, so as Abby said, my name's Reg Harsley. I work for a company called i4 Product Design, and today I'm going to talk to you about our project that was recently funded by Innovate UK. Just to kind of start off the presentation, we are doing some research into research to get some input from people who design for injection molding and also manufacturers of injection molding parts. I'll put up our survey links again at the end of the presentation, but if you do have some time to fill in the survey, I'd really appreciate some of your input. So just a little bit about i4. So we're a product design consultancy, been going for nearly 20 years now. Traditionally, we've done enclosure design and mechanical engineering for products, but recently expanded into electronics and software. We've had a range of clients from medical companies to industrial companies and consumer electronics, or consumer product on the whole. And recently we've started looking at doing more of our own internal projects. So last year we were awarded funding from Scottish Enterprise to develop batteryless products. And most recently, we were awarded the Manufacturing Made Smarter award through Innovate UK. So as Hannah and Hussein mentioned earlier on, we're looking at automating, estimating manufacturing costs, and we're also looking at implementing these through a supply chain management portal. So just a bit about the funding stream that we got. So the Manufacturing Made Smarter award came in two streams. There was the industrial research and there was a feasibility study for the award. We decided to go for the feasibility study because it was a 6-month project, and the idea that we've got for these automated tools are still very young. So it seemed like a good way to kind of test the waters for this particular project. The aim of the Manufacturing Made Smarter award was to kind of improve digital technology or increase it in UK manufacturing, and also look at increasing the sustainability within UK manufacturing. Another key point was increasing collaboration amongst small and medium enterprises. So I'll talk about the team in the next slide. But related to automating costs, one of the suggested themes was looking at improving decision-making through analytics and artificial intelligence. So the team that we had for this Innovate UK project was i4 Product Design as the kind of lead member. So we were kind of using our experience of working with manufacturers and kind of getting estimates in for parts. So we're kind of using our expertise to lead the project that way. We have a company called Houston who are specialists in using artificial intelligence to augment human decisions. We've got researchers from Edinburgh University, one of which I think is in the audience at the moment, who specialise in data-driven design and manufacturing. We also have some other, as well as designing the tech, we've got some specialists from BOC, so they're an industrial gas supplier, so they've designed a lot of their own products. And we've also got McLaren Plastics involved in the project, who are an injection moulding company based in Edinburgh, who i4 Product Design has worked with a lot in the past. I'll talk a bit about what they do in the project later on. So the problem that we wanted to tackle is how can we automate manufacturing cost estimates? So as Hannah kind of mentioned earlier on, as a project kind of develops, costs related to the project increase. This isn't just talking about the design cost, it's literally the amount of money you spend to make a product. So you start putting money into kind of making prototypes, and then you have the upfront costs before you go to manufacturing, and then finally the final cost you get to get your product off the production line. We also have a range of kind of estimates that happen throughout the kind of lifetime of a project. You might have a very wide idea of how much a product is going to cost when you first start it, but it's not really until you get to the product actually comes off the production line and you get that invoice from the manufacturer that you know exactly how much it's going to cost. So we're particularly interested in two stages of getting estimates. One is after what we call the engineering phase. So once we've kind of designed our product in CAD, so can we use our kind of CAD design and get some accurate costing before we send it off to the manufacturer? And also we want to look, can we get some costs just after the requirements phase? So can we get some costs and feedback that might help direct the project in a particular way and kind of reduce overall costs? We're all aware of different materials that can be used for manufacturing, and each material has its own or is suited for particular processes. Within these processes, there's different cost profiles within them. So you might have to invest a lot in tooling, such as injection molding, bill tens of thousands to get your tool kind of set up. But the advantage is you get a cheap part. Whereas if you use something like CNC, the buyer doesn't really see any of that kind of upfront cost, but it does result in a higher part cost. So as part of the project, because it's a feasibility study, we knew we couldn't tackle every single manufacturing process. So the key kind of success of our project was that we managed to kind of limit the scope in a kind of manageable way, but something that was still worthwhile doing. So we decided to focus on injection molding. One reason was because I4 has a lot of experience in designing for injection molding. So we are used to getting costs back from manufacturers, and we have a lot of experience within our team for kind of knowing those, being able to kind of estimate that from experience. It's a common process, particularly for volume manufacturing, and for volume manufacturing, we need to get an accurate costing. There's a slight variation in product cost when you multiply that by tens of thousands or hundreds of thousands, starts to seriously impact your forecasting. So it's really important to get accurate costs. It's also a very complex problem. There's a lot kind of goes into costing these kind of things, and it's still not really a fully solved problem yet, at least anyway. And as well, because it's plastics, because we're doing automated tools, we can give some automated feedback, and we can hopefully try and nudge users or give some more feedback on how they can reduce their environmental impact when they're using plastics, which is obviously a very important thing as a societal problem at the moment is using. We do, as manufacturers, plastics are a very useful material, but we want to use them sensibly and in a responsible manner. So currently how we estimate things, so at the start of a project, you might have some kind of size envelope, and you might kind of know some of the materials that you want. If you're an experienced engineer, you might be able to use kind of previous projects to give some kind of cost, or if you speak to a vendor, you might speak to a kind of injection molding vendor. They have their box of bits that they might rummage through, and then after you've described the part, they pull it out and they go, "It means something like this," and they can give you a cost on that. As you get through to the engineering stage, when you've actually got CAD designed, you might work from engineers' experience, or you send stuff out for quotation to get a rough idea of how much things are going to cost. In the past, I've looked at developing their own tool to estimate these costs, but it still takes a lot of input from experienced engineers. So the whole estimation process still takes a lot of experience and a lot of kind of manual processes, so it can take quite a while. So we're looking to see, can we automate this process? So we're looking at making automated estimators. We're using I4 Product Design's experience to kind of guide these estimators. And for the requirements estimator, we want to input product descriptions in a kind of text-based manner and get some product cost estimates for part and tooling costs, and also get some kind of feedback on requirements. So this is where Houston we are developing their decision kind of AI tools to help give users feedback and costing on this information. We also want to get costings from CAD tools. So we want to upload our CAD files and other production information, such as surface finishes or secondary operations. And again, we want cost estimates for part and tooling costs, and also feedback on any particular features within CAD, within a part design that may be driving the cost to manufacture that specific part. This is where the researchers at the University of Edinburgh are developing tools to create this estimating. Now, we don't want this tool to just be something that I4 uses. We want to make it available to the wider design community. So the plan is to implement this within a wider web portal. So the idea is we'll have a kind of buyer side to the portal where the users can upload requirements or product data and receive these automated estimates from the tools we're developing as part of the project. And if they're happy with those kind of automated costs, they can then send them out to quotation for vendors. So the vendors would receive projects that are specific to their manufacturing process. They can quote on it, or they can start having a conversation with the buyers through the portal about things that are specific to their process. So this is where we're using DOC as a test buyer group and the Claren Plastics as a test vendor group. So that we can try and improve communication between buyers and vendors kind of early on, and hopefully make some new connections that way. Because obviously with trade shows being closed at the moment, it's difficult for kind of new connections to be made. So hopefully this portal can help improve that. I think it's really important that we've got this kind of buyer and vendor vendor members as part of the overall project team. It gives us really good feedback for kind of how projects or how the platform can be used. But as I said before, we're really interested in kind of what the wider kind of design and manufacturing community would kind of want from such a platform. So if you do have a few minutes and you either identify as kind of a buyer for this type of platform, or you're a trade molder, you could just take a few minutes just to fill out these surveys. It would be really appreciated. And we can hand back to Abby. Do you want to take over now?
Yeah, thanks so much, Reg. Great presentation. Really looking forward to seeing that project come to life. And the links in the chat for your surveys as well, if people want to take part and help with your project.
Thank you very much.
Yeah, so we've got a couple of questions have been posted. If anybody else has got questions for the speakers, please drop them in the chat box. But we will kick off with two really great questions that we've had submitted already. So Diego is asking, this is going to be aimed at Hannah, but we might come to the other speakers as well if we've got bits to input. Have NMIS explored the implementation of agile methodologies instead of the phase gate approach?
Yeah, so we have looked at integrating this into our design methodologies, and especially over at the digital manufacturing team. That's something they use quite regularly. And a lot of the digital tools that everyone has been talking about today really massively enable this, especially as Reg was saying, once you get further along your product journey towards verification and validation, one of the drawbacks historically using traditional design methods is that as you get to this stage of modeling, analysis, and performing physical validation activity using a representative prototype, it can become really costly to do iterative design using an agile methodology. But using these digital systems to perform these activities, so looking at digital modeling, digital verification, even digital validation in some cases, it really enables these design processes and increases the communication as well amongst stakeholders, which is again historically been challenging. So yeah, thank you, great question.
Thanks for that. Do any of our other speakers want to come in on that one? Any other thoughts? No. Okay.
I think that's very key. I think the technology is is what is holding or held manufacturers back. I think some of those technologies coming in, we still have some part of the business where we still need to have the actual part to define the process when it comes to that. We have light guide assembly instructions for the operators to train their vision systems and sensors. We need to have the actual part to train them. But again, that's where technology is now catching up with Unities and other coming up, trying to say, actually, you can train the vision systems in a digital environment. So it takes some time, and that's why you need to have these partners to work with you in that journey in a collaborative way, because it's going to take some time, but technology is getting there. And it's going to help you. I think we are 60-70% there in terms of digitally getting that readiness in our planning, in our operations, and technology is moving in fast fast paced. So just work with the right partners, and I think you should be aware of what is available and how you can work with them.
Thanks, Hussein. Yeah,
Can I say something, Abby, as well? I think, sorry, just to add from always start small. There are so many projects out there that start with an ambition to boil the ocean, and the scope can become so large and have so many people within it that you lose the focus, and the thing drags on, becomes hugely expensive, and the momentum goes. If you can find something very small, very specific, very focused, and you can start with something small, you then get people's buy-in, because all this is digital, but none of it will work without the human element. So this is the ability to harness the human element alongside the digital technology at the back end to deliver an overall benefit to the businesses. And if you are out there looking at how to engage with digital technologies, always start small and get everybody on board, because then you will grow. It will grow like a bushfire. Sorry, Abby.
No, that's it. Yeah, that is really important, Francis. Thanks for that. I think that's valuable. Yeah, I guess there's three sort of key things that are sort of coming through as clear. One is that digital really enables better design, better manufacturing. Collaboration is a big part of that. And then, yeah, like you say, there's like the human element to it, getting people involved and taking them with you on the journey. So yeah, another great question that's came in. We'll start off with Carol this time, if it's okay. So it's from David Wallace from Position Systems Limited. David is asking, Carol, are you finding that the latest AR, VR and AI machine learning sort of techniques are helping and even moving beyond the limitations of the human brain, even into originating a new design? Have you got any thoughts on that, Carol?
Yeah, it's a good question. Obviously, that's kind of a work in progress, really, as far as VR and AR environments. AR being the less mature of the two, but certainly, this is our 10th year now building these types of tools, and plenty of times I've seen how virtual reality can help, not necessarily move beyond the limitations of a human brain, but certainly pull more capabilities that we naturally take for granted in the real world, and pulling those kind of those special skills almost into our workflow, rather than, for example, 2D based desktop tools tend to become the barrier that shuts off parts of that kind of human capabilities that we do in the real world, that we kind of lose at work when we're looking into a tiny little monitor. So I used to think about it, if you think about when you're driving a car to work, you're doing lots and lots of different complex things all at once. You may be even talking to a passenger, concentrating on the road, operating the vehicle. It's all very heavy and dangerous, but you just kind of do it almost on autopilot sometimes, because your human kind of psyche is geared up to deal with that 3D spatial environment really, really well, and take in lots of different stimulus from your environment and react to it almost automatically. So virtual and augmented reality pull those capabilities back into your workflow, where obviously they're being cut out now with 2D based tools. I'll just give a quick example of that. So we were talking to a German based automotive manufacturer in Wolfsburg. I can give any more clues. A few years ago, about streamlining the complexities of kind of cleaning up robotic simulations. So they manufacture obviously car parts. They have big industrial presses that stamp out parts, and in between those presses, they have a robotic arm that just grabs a part from that press, puts it onto the next press. Fairly simple, but the motion of that robot is all calculated via software, machine learning software, that generates the most optimal path for that robot to travel as that press, so the press can keep moving at speed. So no time is lost and productivity is up. But inevitably with most software, you always needed an expert to come in, a human, to take a look at that after the output was generated, to fix millimeter clashes. So the software was approximating a good curve, but not quite. there were millimeter clashes where the robot would just clip the press, and obviously the whole thing breaks and shuts down. So what we did is we then pulled that into a digital twin environment where you have, you're standing in between these presses. You can see the robot moving. You can even see the 3D motion path that robot takes. And currently, to fix these millimeter clashes in the real world now, experts are using spreadsheets. It's just X, Y, Z coordinates. They're by trial and error. They're just, okay, I'll move X up a little bit. They run the simulation again. Oh, no, I have to move X down a little bit, run the simulation again. And it's all very laborious and complicated and abstract. So within this 2D environment, this 3D environment that we've created, we actually got, to prove the point, I got my mum, who's not a robotics simulation expert or an engineer, in the environment, and just to look at what was happening. And in the VR, obviously it's very spatial. You're able to recognize exactly where the problems lie. You can say, okay, I can see it's clipping this bit here. You can see the motion of the robot. And the tools that VR allowed was just to bring, naturally fix that without spreadsheets. She was able to grab the robot simply at the point where it was clipping and just pull it down slightly in the 3D space, just like you would move a coffee cup on a tabletop. And then that edit that we just made generates a new curve, and that curve then can go back out to the machine. So within 30 seconds, a non-skilled person can go and perform a task that a highly skilled engineer would take hours to do using an abstract 2D spreadsheet in the real world. So they're the types of things that VR and AR and spatial and collaboration environments can start to introduce into the workflow, removing these abstract barriers and start pulling through things that we can just do in the real world without even thinking almost. So sorry for the long-winded answer, but I think the example there kind of speaks for itself, I think.
Yeah, great example, Carol. So I'm going to ask one more question. It's been directed at Hannah, but I'm going to come to Reg first because I'm interested in getting his perspective on it, and then Hannah, we'll jump over to you. So it's about validation rules. So do you have validation rules in your cost model? Is that something you've thought about as you've been developing tools?
It's something that we want to try and include. So the key thing we're focusing on at the moment is we want the costs to be more accurate, but as part of a kind of useful tool for designers to be able to give that feedback of, you've got some clips here that are going to require some